We're going to talk about something today called a counterexample. To show that a conjecture is true for all cases, you must prove it. And we will learn how to do that later. It only takes one example that contradicts a conjecture, however, to show that a conjecture is not always true. Only takes one example to show that a conjecture is not always true. This example is called a counterexample. And one of the things that we need to know about conjectures is a conjecture is either something that is true or something that is false, not a sometimes thing. If a conjecture is not an always true statement, then it is false. If a conjecture is not always true, then it is false. If a conjecture is not always true, then it is false. So, when I'm reading a conjecture, if I can think of some situations where it's true, that does not make the conjecture true. If I can think of even one place where the conjecture is false, then the whole conjecture is false. It has to be an always true statement to be true. All right, so let's look at example number 9 here. It says, find a counterexample to show that each conjecture is false. A says, if n is a real number, then negative n is a negative number. Okay, but what if n is equal to negative 4? Do you guys agree that negative 4 is a real number? Not a fake number? We have a real number. It's a negative number, but it's a real number. So if n is equal to negative 4, then negative n would be negative 4. Well, what happens when you have a negative after a negative? It becomes a positive. So remember, my conjecture said if n was a real number, I picked out something where n was a real number, then negative n is a negative number. Did negative n come out to be a negative number? No. So this is false. And this is our counterexample. This is my counterexample. Negative 4 is a real number. But negative 4 is not a negative number. So the counterexample is the thing that makes the first part of the statement true, However, the second part of the statement would be false. So I found a number that met the first part of the criteria. N was a real number, but the second part of the statement was not true. All right, let's look at example B. If angle ABC is congruent to angle DBE, then angle ABC and angle DBE are vertical angles. So first thing I want to address is, could I draw a situation where ABC and DBE are vertical angles? Could I draw a picture where they really are vertical angles? Yes. My task right now, it says draw a diagram to represent the counterexample. I want to draw a diagram to show that this doesn't have to be true. That I can draw a picture where I have angle ABC and angle DBE, but they are not vertical angles. So let's draw this picture. All right, I'm going to call this my angle ABC. I'm going to have A here, B here, and C here. Angle DBE, notice they have the same vertex. They both have a vertex of B. So B has to be the vertex for angle DBE, but it doesn't share any of the other same points. So I can have an angle that looks like this. I can have D here and E here. Angle ABC is congruent to angle DBE, but they are not on opposite sides of the X. So this would be my counterexample. Because in this picture, angle ABC is congruent to angle DBE, but angle ABC and angle DBE are not vertical angles. So our conjecture is false. If I can draw or think up one example where the conjecture is not true, then we say the conjecture is false. All right. Let's look at C. C says if n is a real number, then 1 over n is less than n. Well, what if n equals 1? If n equals 1, then 1 over n would be 1 over 1. What is 1 over 1? That'd be equal to 1. Is that less than 1? No. 1 is not less than 1. This is false. So n equals 1 is my counterexample. Over here I can say 1 is a real number. But 1 over 1 is not less than 1. Example D says if a line intersects a segment at its midpoint, then the line is perpendicular to the segment. If a line intersects a segment at its midpoint, then the line is perpendicular to the segment. We are supposed to draw a diagram to represent the counterexample. So first I'm going to draw a line segment. We're going to identify its midpoint. These two sides would be congruent if that's really the midpoint. If I draw a line that goes through this center dot, does it have to be a straight up and down line like this? No. I could have it tipped like this. Is that perpendicular? No, because perpendicular means that it has to form a right angle. So this would be false. This picture is my counterexample. In this picture, a line intersects a segment at its midpoint. But the line and the segment are not perpendicular. In this picture, the line intersects a segment at its midpoint, but the line and the segment are not perpendicular. Now, on your homework that is due tomorrow, there are several questions on the back side where it asks you to come up with counterexamples. Your counterexamples can be a number, like in part C, where we had to think up a number that made the first part true but the second part false. Or your counterexample can be a picture, depending on the situation that they're presenting you with. Sometimes you want to draw a picture to show, here's a situation that made the first part true. We had a line intersecting a segment at its midpoint, but it made the second part of the statement false. All right. That concludes the part of the notes that you need to complete the homework for tomorrow, but we are going to go ahead and push forward in your notes. That's a question for after our normal class time. All right, so we are going to go ahead and push on and look at the part of the notes where it says statements, conditionals, and biconditionals. A statement is any sentence that is either true or false, but not both. It's either true or false, but not both. The truth value is the truth or falsity of a statement. Statements are often represented using letters such as P or Q. If a statement is represented by P, then not P is the negation of the statement. The negation of a statement has the opposite meaning as well as the opposite truth value of the original statement. The negation of the statement is not P, or we have this symbol right here to mean not. A squiggle in front of the P. That means not. Two or more statements joined by the word and or form a compound statement. A compound statement using the word and is a conjunction. A conjunction is true only when both statements that form it are true. A conjunction is written as P and Q, or P and then this like arrowhead that points up. This means and. For this to be true, both statements that form it have to be true. If I were to say, I'm wearing a black sweater and I'm wearing red shoes, that would be false, because while I am wearing a black sweater, I am not wearing red shoes. Both statements have to be true for the compound statement to be true. So if I said I'm wearing a black sweater and I'm wearing black shoes, that would be true because I am wearing a black sweater and I do have black shoes. So both parts have to be true. A compound statement using the word or is called a disjunction. A disjunction is true if at least one of the statements is true. A disjunction is written as P or Q. We have this symbol right here. Looks like an arrowhead pointing down. That means or. All right. So in order for a disjunction to be true, we only need one part of the statement to be true. So if I were to say, I am wearing a black sweater or I am holding a yellow folder, that would be true. I'm wearing a black sweater or I am holding a yellow folder. One of those statements is true, so the whole disjunction is true. With an and, I need both parts to be true. With an or, I just need one part to be true. They can both be true, but they don't have to both be true for an or to be true. All right, let's flip over to page 4. And let's look at some of this. So we have 3 statements here about this figure. My first statement is the figure is a trapezoid. Is that true or is that false? That is false. That figure is not a trapezoid. The next statement, which we are calling statement Q, is the figure has 4 congruent sides. Is that true or false? That is true. The last statement, statement R, is the figure has 4 right angles. Is that true or false? That is also true. All right, so we're going to write the conjunction or the disjunction. First, we're going to do part A where it says P and R. We're going to write out this sentence in English. Right now it's been written in logic notation. We're going to write this out in English, and then we're going to decide whether this is a true statement or a false statement. So we have to start with statement P. What is statement P? The figure is a trapezoid, so that's what I'm going to start off by writing. The figure is a trapezoid. And then we have the and. So I'm going to write and next to it. Then I need statement R. What is statement R? The figure has 4 right angles. For an and to be true, I need both parts of the statement to be true. Is this first part true? No, that is false. What about the second part? Second part was true, but this is an and statement. So is the whole thing false or true? False. For an and statement, we need both parts to be true for the statement to be true. All right. Looking down at part B, we have a couple symbols thrown in here. What does this squiggle in front of the P mean? Not. And what does this arrowhead pointing up mean? And. So I need not P. Well, P is the figure is a trapezoid. So how would I make that not P? Correct. The figure is not a trapezoid. The figure is not a trapezoid. And then that next symbol after not P means and. So we have and here. And then we need statement Q. What was statement Q? The figure has 4 congruent sides. All right, so let's go through and figure out the truth value. The figure is not a trapezoid. Is that true or false? That is true. The figure has 4 congruent sides. Is that true or false? That is true. This is an and statement. In order for an and statement to be true, I need both parts to be true. Are both parts true? So the whole statement then would be true. Nicely done. Let's try one more like that. One more like that. Number 2, use the statements to write a compound statement for the disjunction. Ooh, let's look at these symbols here. We have P, and then we have the arrowhead that points down. What does that mean? Or. And then the squiggle in front of the R means what? Not. So P or not R. Well, let's look at these statements. We'll decide whether the statements are true or false. Then we'll write our compound statement. And then we'll decide whether the compound statement is true or false. Angle ABC and angle CBD are complementary. What does complementary mean again? Add up to 90 degrees. So together they make a right angle. Is that true or false? Do angle ABC and angle CBD make a right angle? No, so this would be false. Angle ABC and angle CBD are vertical angles. Is that true or false? That one is false. They are a linear pair according to the picture. They are not vertical angles, but they do form a linear pair. Segment AB is congruent to segment BD. Is that true or false? That is true. All right, let's write the compound statement that they asked us to write. We are supposed to write P or not R. So I'm going to recopy statement P, angle A, B, C, and angle C, B, D are complementary or, and now we're going to write not R. Well, what would not R be? Segment AB is not congruent to segment BD. All right, so let's look at this now. We already said that this first part of the statement, ABC and CBD are complementary, is true or false? False. AB is not congruent to BD. Is that true or false? That is false. For an or statement to be true, I need just one part of that whole statement to be true. Did we have any piece of that statement that was true? No, then this is false. If we had had even one part of it be true, then the whole thing would be true. All right. Let's talk about conditional statements. A conditional statement is a compound statement that consists of a premise, or a hypothesis we call it, and a conclusion, which is false only when the premise is true and its conclusion is false. An if-then statement is a compound statement of the form if P, then Q, where P and Q are statements. So this is how it would be written in symbol form, P and then an arrow Q. We would read that as if P, then Q, or P implies Q. The hypothesis of a conditional statement is the phrase immediately following the word if. Or implied if. Sometimes when we have if-then statements, we don't actually write the word if. I'm thinking about my 9-year-old this past weekend. She asked me if she would be allowed to play Minecraft yesterday. And I said, go clean your room and you can play Minecraft. There was an implied if in there. It was if you go clean your room, then you can play Minecraft. So even though I didn't use the word if, it was in there. The conclusion of a conditional statement is the phrase immediately following the word then, or implied then. And our example here is, if it rains, then the parade will be canceled. So it rains, is my hypothesis. The if is not part of the hypothesis. The hypothesis is the part that comes after the word if. Then the parade will be canceled. So the parade will be canceled is my conclusion. So we have to be careful when we're reading things in English, because sometimes in English we like to switch up the order of our sentence. And sometimes the way you would read something in English would have the conclusion first, and then it would have the hypothesis, like the parade will be canceled if it rains. But the it rains part is still my hypothesis. Even though it came at the end of the sentence, it came after the word if. All right, let's flip the page and practice this a little bit. We're going to practice identifying the hypothesis and the conclusion. My first statement, if a polygon has 6 sides, then it is a hexagon. This is an easy one for us to start with. So I find the hypothesis because it comes after what word? If. Well, what comes after the word if? A polygon has 6 sides. Yes, that is my hypothesis. Polygon has 6 sides. The conclusion comes after what word? After then. What comes after the word then? It is a hexagon. So I have to be really careful here, because while I can write it is a hexagon, if I'm just bringing that up as my first statement to somebody, they're going to have no idea what I mean if I just say it is a hexagon. They're like, sure it is. So I need to replace that word it with what it means. What is the it here that we're talking about? A polygon. So I would say a polygon has 6, or is a hexagon. A polygon is a hexagon. When we're writing things in English, it is normal to not repeat the subject of the sentence twice. We would use a pronoun like it. But when we're writing out our hypothesis and our conclusion, we want to put what is the subject of the sentence there. We don't want to use a word like it. All right, let's look at example B. Another performance will be scheduled if the first one is sold out. How do I find the hypothesis again? After the word if for my hypothesis. Well, what comes after the word if? The first one is sold out. The first one what? The first performance. So that's my hypothesis. The first performance is sold out. The first performance is sold out. So what would my conclusion be then? Another performance will be scheduled is my conclusion. All right. Part C, if the forecast is rain, then I will take an umbrella. What is my hypothesis? What'd you say? Super close. There we go. If is my signal word, but it does not get included as part of the hypothesis. So the forecast is rain. The forecast is rain would be my hypothesis. What would my conclusion be? My hypothesis is the forecast is rain. What is my conclusion? I will take an umbrella. Nicely done. All right, let's look at the next one. A number is divisible by 10 if its last digit is a 0. How do I find the hypothesis again? What's my signal word for the hypothesis? If. Do you guys see the word if in there anywhere? Yeah. What comes after the word if? Its last digit is a 0. Remember, I don't want to use a word like it. What do we mean by it? A number. A number's last digit is a 0. So what would my conclusion be then? If a number's last digit is 0 is my hypothesis, yes, a number is divisible by 10. Notice my hypothesis and my conclusion are each sentences that can stand by themselves. These are sentences that should make sense all by themselves. All right, let's do number 4 and call it a day. Let's look at number 4. This one's a little bit trickier. We are being given a statement. We need to identify the hypothesis and the conclusion, and then we're going to write it in if-then form. So my statement is 4 quarters can be exchanged for a $1 bill. So what would have to happen first if you're going to do this? What would you have to have first? What would our hypothesis be here? Close. You're very close. I like it. You're going after the first part of the sentence. So we're going to start with this piece right here. 4 quarters. Now that's not a whole sentence by itself, right? But it would be a whole sentence if I said, you have 4 quarters, right? And if you have 4 quarters, what can you do with them? Then you can exchange them for a $1 bill. So my hypothesis is you have 4 quarters. My conclusion I have to change into a full sentence as well. So I have to change this into a whole sentence that can stand by itself, can be exchanged for a $1 bill. So I can say something like, you can exchange your quarters for a $1 bill. Something like that. I have to make it into a whole sentence that can stand by itself. So you can exchange your quarters for a $1 bill. So then my if-then statement, so now I'm going to write it with the words if and then. I'm going to write if and my hypothesis and then a comma and then and my conclusion. So if you have 4 quarters, then you can exchange your quarters for a $1 bill. All right. Bell's going to ring here in about 30 seconds for the announcements, so we're going to stop there and we will do part B tomorrow along with part C. Homework is due at the beginning of class tomorrow, don't forget. And what we did up through halfway on page 3 is what you need to complete that assignment. Halfway through page 3, so pages 1, 2, and half of page 3 is what you need to complete your homework that's due for tomorrow.